Okay, hi, Assalamualaikum. My name is Farah Anis Nabila binti Sharifudari. My meter number is CE190237. Today I will present about introduction to low voltage switchboard Lvsb. Okay, today we show the figure 7.3 schematic control diagram for main incoming. Okay, start from the bottom. Incoming supply, three-phase AC supply. Okay, we have in the first layer, I just assume this is start from here to here. This is the first layer. Okay, we have R, Y, P, and earth to connect with kWh or kilowatt hours meter. Okay, directly from here to here. Okay, next we move to the second layer, which is colored. From here to here. Okay, and also here RYB connect with MCB to the main supply. We have three wires R, Y, and B. Okay, next for the third layer, in here. Okay, this is our heater. Okay, and also MCB to switch to heater. In Malaysia is not useful. Okay, sorry. Okay, next for fourth layer, this is ST ocean trips. Okay, as we can see here, to here is IDMT. Okay, OC stands for overcurrent and EF stand for earth fault. Okay, for R, Y, and B is connect directly to overcurrent. Y for neutral and fault is connect to earth and fault. Okay. 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 Next for the last layer is connect with emitter selector and voltage selector. Okay, in bus bar we have four line R, Y, and RYB and neutral. Okay, as we can see here, connect to bus bar supply to VS, and also here RYB connect to AS emitter selector. Okay, but from here R is connect with PF directly to this line to connect with VS. Okay, and that's all. Thank you.
Okay, today I'm going to explain about figure 7.4 schematic control diagram for outgoing feeder CHW 4 relay. Before I go to explain, my name is Benjamin Ho Hao Xian, normal metric CE 210053. Okay, for relay D is to protect a fault and used to the MCCB. Okay, for MCCB here we use 100 ampere and link to the SD, which is shunt trip. SD is shunt trip. When shunt trip is energized, this will cut off the supply because detection of fault to protect the circuit system. Okay, for incoming main bus bar, which we have four: red, yellow, blue, neutral. Okay, for the three phase voltage, we use 415, and single phase is 240, and the frequency is about 50 Hz. For the incoming, link red, link to the 6 ampere MCB and connect to the 4 relay. And next, 2 XTB also link to the 8. The TB, the function of TB is to terminate the wire. Okay, TB is terminal box. Next, we coming to the current transformer, which has four 100 voltage and 5 ampere. And every bus bar let's connect to the transformer: red, yellow, blue, and neutral. Okay, and finally conduct to the S1, and the current go into the 4 relay. 7 is connect to the ground, and which connect to the every bus bar. So totally the current transformer is going to the load, every load of the bus bar. Okay, that's all for my present. Thank you.
Good day everyone, my name is Ishwarjit Singh, matrix card number CE200095, and today I'll be explaining about the figure 7.5, which is schematic control diagram for outgoing feeder earth leakage relay. Alright, so first of all, this supply is coming from the main bus bar going to the load. Alright, so for 3 phase it is 450 volt, while for the single phase it is 240 volt. The frequency is 50 Hz and this will be AC supply. It will go through the feeder, which is this earth leakage relay. There's 4 load line, which is red, yellow, blue and neutral. The current will pass by the MCCB. This symbol is MCCB. Stated here is 60 ampere TPN MCCB. Alright, so when it is on, it will make contact and our load will be getting the supply. This whole thing or circuit here is protection circuit, which is the earth leakage relay. ZCT component here is zero phase current transformer. Basically ZCT series are compact molded type zero phase current transformer. They are ideal for improving the sensitivity, compactness and weight of electric shock prevention. Right, so these zero phase CT are differential sensors passing both line and grounded neutral conductor into the CT aperture so as to make zero phase sequence in the case of leakage current or fault current on the line. So it is called the differential current as the sensitivity current distinguished from the primary current. Right, so over here we have got ELR, which means earth leakage relay, also known as ground fault relay, which are residual current monitor that are used to detect potentially dangerous ground fault current before they can cause any hazard. Right, so causes of ground fault current are usually inadequate installation due to mechanical damage of cables or devices. In figure 7.4 we saw that the schematic was of earth fault current, and this one is earth leakage current, earth leakage relay. So the difference between both of these earth fault relay can work only when the earth fault current flow through the earthing or grounding conductor, but the earth leakage relay can work for both, for earth leakage current flowing from anywhere in the electrical circuit. Alright, so moving on, when this ZCT detects the current, for example 0.5 ampere, or if the fault exceeds 0.5 ampere above, the relay will detect, and this will give the output to the switch here, and make contact. Shunt trip coil will get the 240 volt. Right, so this ELCB over here, ELR, will disconnect the power when earth leakage is detected, and then when it, when the fault current is detected from live to the earth with the ground wire within the installation, it can protect the circuit. Right, so this point here and here are the input. This XTB means terminal block. When the shunt trip coil is energized, this will cut off the supply because the detection of fault. Right, and this connection here going to over here, this is auxiliary supply. Right, that's all from me. Thank you.